Now that we have everything set up, we're going to move on to our scanning experience. In this chapter, we're going to learn how to use the Surface Observer to gather spatial mapping data. We're also going to consider some performance impacts that spatial mapping can add to your application. And then we are going to learn how to save a room so that we can load it into Unity and help speed up our application development. So from the moment you turn on your HoloLens, it's constantly scanning the environment. But it's up to you to decide when and how often you want your application to access that data. So when designing your app, you should think about when and how you want to use spatial mapping. Do you need spatial mapping for placement of objects, for navigation? Will your holograms be moving with the user along a surface? Will your user be moving from room to room while interacting with your app? So in our class today, we're going to be doing a one-time scan because we do want to do some processing later on in the course. So the first thing we need to do is actually add our spatial mapping component. You can find that in the Holo Toolkit folder, prefab section, and drag and drop the spatial mapping object into the hierarchy. The Spatial Mapping Manager communicates between the Spatial Mapping Observer and your application. It performs real-time updates on the rendering and collider objects. When you tell the Surface Observer to start running, this is going to result in on-surface changed events being fired whenever a surface data is added, updated, or removed. In the case of adds or updates, our app will create a new game object in order to store mesh and collider information. And then we're going to call request mesh async to fill in the mesh data for our surfaces. Once request mesh async is done, the on data ready event will fire, and our app will have a usable mesh to display and colliders for use with our physics raycasts and our collisions. And then the final component on our spatial mapping prefab is the Object Surface Observer, and we will touch on this a little bit later in the chapter. So we're already ready to begin our build process. Go to the File menu, select Build Settings, click the Add Open Scenes button, make sure that Planetarium appears now, select Windows Store for the platform, and press the Switch Platform button. Let's change SDK to Universal 10, UWP build type to D3D, and let's check the Unity C# projects so we can have IntelliSense. Now press the Build button, and let's create a new folder. Name this folder App, APP. And then select that folder, and Unity will begin building and exporting our project for Visual Studio. Once it's done building, a new File Explorer window will appear. Drill into the App folder and select the Planetarium Visual Studio solution. Open it up in VS. Now we need to set our build settings. On the little debug drop-down, change it to release. Change ARM to x86. And change local machine to remote machine. Now type in the IPv4 address of your HoloLens and press select. And we are ready to build and deploy. So go to the debug menu and select Start Without Debugging or press Ctrl F5. So you just saw the spatial mapping mesh rendered as a wireframe, and hopefully you saw that there were a lot of triangles suddenly added to our world. Let's see what type of a perf hit we get by adding all of those triangles. Now, Unity provides a profiler for us to use. Let's go ahead and go to the Windows menu and select Profiler to open it. Expand that. Let's select Add Profiler and GPU so we can see the GPU profiler. Now this will add some performance hit to your application when running with the GPU profiler, but it will at least give you a general idea of where your application is having performance issues. So let's attach to our HoloLens by selecting the active profiler, entering your IPv4 address of your HoloLens, and press connect. Right now we see that the CPU usage is selected and we're getting a pretty good frame rate. 100 frames per second, that's pretty good. Let's move on down to our GPU. And in the bottom section in the overview, we can drill into different areas to see maybe where the most time is being spent. Let's just look at our draw calls real quick. For our current level of detail. So currently we have the spatial mapping mesh rendering 500 triangles per cubic meter. And we can check our draw call is about 0.229. Let's try changing our level of detail. So let's go ahead and check, open up the spatial mapping observer. And then navigate down to the awake function and then type in triangles per cubic meter equals 1200. And this will force our spatial mapping meshes to be rendered at a higher triangle count. So we can go ahead and just launch this again on our HoloLens. If we go back to Unity, we'll need to reattach to our HoloLens since we had stopped and restarted the process. And we'll see we got a bit of a drop in our frame rate. And our draw calls, oh, they really haven't changed much. This can be different based on what your HoloLens is looking at on the time. Right now, I'm staring at a wall, which doesn't have a whole lot of detail, so we didn't see much of a dip in our rendering. And before we continue, we want to go back to Visual Studio and remove that line. 1200 is running at a high LOD, and we want to be medium. So removing it will just put us back at 500, which is our medium LOD. And we're just going to rebuild, make sure everything's good. Our next step is that we want to save the spatial mapping data and then load it into our PC so that we can use it in Unity. And in order to do this, we need to open up the Windows device portal and navigate to the 3D view page. Once you're on that page, find the update button and press it. So as long as your HoloLens is running, it's going to be transmitting our spatial mapping data to this view. We'll be able to see what we have. If that's a good capture that you want to save, go ahead and press the save button. And then you can open the folder location and it will be saved as spatial mapping. Let's copy our spatial mapping object and then we're going to drop it into the assets folder of our project. So navigate to our assets folder and just drop it right in there. If we switch back to Unity, Unity is going to load that new object up, and we should see a spatial mapping object right there with our little room. Now to load this object, let's go to the spatial mapping prefab. I mentioned the object surface observer earlier. Just drag a reference to our spatial mapping object here, drop it. And now when we run in Unity, it's going to load up our room. So you're going to see the mesh in Unity. If you switch to the scene view, you'll be able to easily zoom in and out and see the entirety of the mesh. So awesome, we don't have to jump between the HoloLens and Unity so much in order to be working with spatial mapping. We can do all of our testing within Unity now. Now that we know how to access spatial mapping data on the HoloLens and load a room model into Unity, we are ready for our next chapter, where we are going to really visualize our space using shaders.